Your first homework is now up, and again, to access, okay, again, you'll click on Alex, and then click on the McGraw-Hill campus link, and then Alex, and you're going to click on Alex. And since I have like names and numbers on the introductory page, what I decided to do is to just kind of go into an already loaded up page in Alex, just to kind of keep things as confidential as much as possible. And there are a couple of categories here, and we have, just with the calendar, the stuff that has like the section R1 and I2, those items that have the circle or the pi symbol around them. Those particular items are optional, but they are not mandatory. But now anything that has like Alex homework, like homework section R4, that part is mandatory. Anything that has the box with that has the green outline with the pencil and lines in the middle, okay, that is where the Alex homework comes in. But anything that has like the stuff that's like due May the 6th, okay, that particular group is optional. It's just for practice. But for stuff that is to be graded, anything that has like a lifespan in terms of the availability, okay, that stuff is mandatory. And to just kind of give you an overview of the assignments. Okay, so you're going to have a like first item, and the dates can change, but anything that has the outline with the pencil icon, like have Alex homework section R4 and factoring, and then like next would be section R5. You have like your start and due dates. But, and again, you'll have these items, and again, we're looking at sections from chapters R1, 2, and 3. But at the bottom of the list, okay, we have the circle icons. I know that some of you have asked about this, like if those particular items were due. I know it has HWK like homework, but the Pi progress stuff, that is not due. And to kind of give you sort of separating the wheat from the chaff, so to speak, anything that has, like, if you notice in type, anything that is homework, that is to be tended to. But anything that is objective in essence is optional, and anything from the Pi progress, if it's objective, it is optional. But for homework, that is mandatory, and that's where the Alex homework is figured in, okay, for the course grade. And now, just kind of give you an idea of what to anticipate. Say if you are looking at going into Alex for the first time, and what we'll do here is that just say like entering the student view. Say if you're going into Alex for the first time, okay, you're going to have like a tools tutorial, and okay, just kind of giving an introduction. Yeah, let's get started. Okay, and it has just like your main menu, and I'm going to get into that in just a moment. And just click on the next in the boxes, and you have an introduction to Alex tools, get started, and it goes into the stuff like it introduces you to the calculator and how to use the keyboard. And I'm just going to skip the tutorial. Okay, and I have some like once you're through, you have like congratulations, your name, you've completed the tools tutorial. And then we have in the next round, okay, you're going to have what's referred to as an initial knowledge check. And this would be made up of about around 30 questions. And I know that some are like, so I didn't know too much material that was in the diagnostic. And that is already pre-programmed by the publishing company. I wish that you all did not have to go through those questions. You're not graded on them. It's just kind of like a diagnostic. And you have like, it says before you start your initial knowledge check, and you have just recommendations. And again, it's just a diagnostic. Okay, you have, okay, start knowledge check, and you have like sample question, you have like solving for x. Okay, this is just like writing in terms of x equals, and again, if even if nearly all of the problems, if not all the problems, are outside your zone of familiarity, so to speak, don't worry. Again, you're not graded. Again, it has a blend of all the current and future topics in the mix, so you're not by any means expected to already know half or even all of the material. Probably not even have a certain level of familiarity, even at the, let's say, even the 10 or 20% level, especially if you're looking at pre-calculus for the first time. And go through like 30 questions. And what I'm going to do here, just skip the knowledge check, which I can do since I am the instructor. And like once you go through the rounds, you'll have like a sort of a pie progress. And I'm just going to continue. And in terms of what we have here, okay, in terms of where the homework will be located, okay, and I will have this part in today's video. What you're going to do here is that to access the assignments, again, the main menu, okay, is going to be the 3 bars. So whenever you start it out, or if you start out, you'll probably see just like, just 4 items like home, knowledge check, and a couple of other things like calendar. But after the round of the tutorials and the initial knowledge check, okay, this is where you have assignments. Okay, and again, stuff that is objective, again, that is optional. But homework, that is the mandatory part. And so to access, okay, you have these items, and again, you're going to have an unlimited number of attempts. So if you don't get all the problems right the first time around, you can do the ones you did not get done right and have another attempt, and the best score out of the attempts will be recorded. Okay, so if you were to go into start, and okay, so you have like maybe factoring, and say if you're to go into factoring, or say if you wanted to transition over to working with fractions and then simplifying, and it says, you know what, I'm going to put this problem on hold. Okay, so you have something that doesn't have, let's say, quadratic expressions, but you have combining terms that already have the same denominator, and then simplifying. Okay, and then let's say if you're about to begin and then something comes up, what you can do is that you can just save the set for later, and then just access later on. Okay, and then again, just for the assignments list, okay, so you have to this part, we have available, and that would be due the 20th. And I just want to mention just some of the details that we do have regarding the assignments. Okay, so again, you had the initial knowledge check, and just some of the details on the assignments, because I think like the first item will have 10 problems. Okay, but the way that we have things set up, okay, is that yeah, okay, so for the content settings, you can access the ebook, look at an example, explanation, and you're going to have an unlimited number of question attempts, okay, or unlimited in the sense that you can attempt as many times until the deadline. Okay, and you have an unlimited number of assignment attempts. Okay, and let's say you have like 7 out of 10 correct. Okay, if you were to attempt once again, you do not have to take all 10 problems again. What we're looking at is that you have a quick retake, and students only retake the incorrect problems. Okay, so if you got 7 out of 10, you have a chance to add on to that 70. So it's not like starting from scratch all over again. That 70 is already preserved, and what you can do is that you can add to the score, attempting the incorrect portions of the homework. And in the grade book, okay, the best score will be recorded. Okay. And once again, so just access once again. So you have again, you have the 3 bars, assignments, and again, if it has homework, that means that that is an item that has to be tended to. So you have section R4 in factoring. Okay, so that is due today, and the deadline is next week, 1 week from today at 11:59 p.m. All right, and now in terms of the material, okay, and we have going back to page 51, and we're looking at once again factoring and also blending in with rational expressions. And for number 17, okay, we have a 2-part problem here. In essence, you're looking at taking the ratio and simplifying, and also taking what would be regarded as restricted values. Okay, so we have an x squared minus 9 over x squared minus 4x minus 21. So if we look at factoring, okay, so x squared minus 9, that's going to be a difference of squares. Okay, so this would factor out to x plus and x minus 3. And for x squared minus 4x minus 21, okay, so in factoring, okay, x squared goes to x and x. And factors negative 21, whose sum or difference will be at negative 4. We have more weight given to the subtraction than to the addition. And if you notice between the expressions, okay, we have x plus 3 shared in common. So we can get these to go out. And so the completely reduced form of what we have in the ratio is going to be x minus 3 all over x minus 7. And there's another portion, okay, that will be what is referred to as restricted values. And what this means is that for restricted values, we're going to have that the denominator cannot be 0 in value. And what this means is that now, if you have a fraction, now the bottom number of a fraction can be anything except 0. So just looking at what we have in the original ratio, okay, so you have x squared minus 4x minus 21. That's the denominator. This cannot be 0. And that means that if the whole expression in the denominator cannot be 0, then neither can its factors. Okay, and we had factored out this trinomial to x minus 7 and x plus 3. And if the expression cannot be 0, neither can its factors. Okay, so to avoid a 0 denominator, okay, x minus 7 cannot be 0, nor can x plus 3. So if x minus 7 cannot be 0, okay, we have x cannot be 7. As for x plus 3, if this cannot be 0, then we have that x cannot be negative 3. And so this is going to lead to what we have for the restricted values. In other words, the restricted values would be those values of x that are not allowed in order for the expression that we have in the ratio to be defined, and that is to avoid having a 0 value denominator. Okay, so we have restricted values. Okay, so we have those at 7 as well as negative 3. All right, and for what we have in the Next item, okay, have a bit of partial history to repeat, despite having a different letter to work with. Okay, so in 18 now we're going from x to y, and in the numerator we still have once again a difference of squares, this time with y squared minus 64 all over y squared minus 7y minus 8. And looking at factoring, okay, so we have in the numerator, once again we have the difference of squares, so this will go to the quantity of y plus 8 times that of y minus 8. And for the trinomial, y squared minus 7y minus 8, factoring is like what we did with x, but this time with the letter y. So we have factors of negative 8 whose sum or difference will be at negative 7. Okay, more weight will be given to the subtraction than to the addition. And so we're going to have more weight again with the subtraction than the addition. So the product of these terms will go to that particular trinomial. And once again, we have common factors between the numerator and denominator with y minus 8. And for the complete reduction, we have the ratio in number 18 to simplify to y plus 8 all over y plus 1. And in terms of looking at the restricted values, again, we cannot have a zero-valued denominator. Okay. So again, we have y squared minus 7y minus 8, okay, cannot be equal to 0. And so again, we're looking at factoring once again. And let me mention, okay, now because y minus 8 cancels out in the simplifying process, it does not undo the restriction that is created by y minus 8, because even though we have simplifying, you're still looking at the conditions imposed upon the original form. The original form only, nothing that follows. Okay, so again, we're keeping y squared minus 7y minus 8 from being 0, regardless of what factors are reducible or cancelable or not. Okay, so you have for y minus 8 and y plus 1. Okay, we have the factors cannot be 0. So for y minus 8, if that cannot be 0, we have that y cannot be 8. As for y plus 1, y cannot be equal to negative 1. And so we have for the restricted values, okay, there's going to be 8 as well as negative 1. Now, okay, so 17 and 18, we're looking at simplifying and identifying the restricted values. Now, for what we have in the case of 28 and 41, for what we have in the case of number 28, okay, there's a blend of factoring and also reducing what we have with exponents. And here we have in 28, we have 8x minus 3y all over x to the third, y to the fourth. And we have times, okay, we have 6x, y to the eighth. And we have all over 24x minus 9y. Okay. And what we can do here is that out of the terms from which we can pull out a common factor, okay, nothing between x and minus 3y, or x cubed and y to the 4th, or 6x y to the 8th. But with 24x minus 9y, there is a common factor with 3. So if I treat the second denominator, once again by drawing out 3 as the greatest common factor, okay, and drawing out 3, okay, so we have 3 times, okay, the quantity of 8x minus 3y. And notice that we have, upon factoring, okay, we have 8x minus 3y common to both numerator and denominator positions. So we can get these to cancel out. And also I could have simultaneously, okay, 6 over 3 to reduce, but I'm just going to bring this to the next step. Okay, so you have 6x y to the 8th. You have all over 3 times x cubed y to the 4th. And just for the interaction here, okay, now we have for 6/3, okay, so 3 will go into 6 2 times. And for x y to the 8th, now just standalone x you would read as x to the 1st. And in terms of the ratio that we have upon simplifying, okay, so you got 6/3 reduces to 2. Now for x to the 1st over x cubed, then we'll have the quotient property, and you will be looking at taking the lower degree from the higher power. And so between x to the 1st and x cubed, okay, we'll have the higher power in x resides in the denominator. So we'll be looking at x to the 3 minus 1. And for what we have in y, we have y to the 8th over y to the 4th. And the higher degree in y is in the numerator, and so we'll to have in reducing, again, taking the lower degree from the higher. So you have y to the 8 minus 4. And so for what we have in the result, we're going to have 2 times y to the 4th all over x squared, and that will be the result. Now, in looking at what we have in combining fractions, okay, so here we have m squared over m plus 3. And we have plus 6m plus 9 all over m plus 3. Now we have the same denominator. Okay, so I can go ahead and combine the numerator terms. Thus we have m squared plus 6m plus 9 all over m plus 3. And looking at factoring, m squared plus 6m plus 9, this will factor out to m plus 3 times itself. All over m plus 3. Okay, so we have an m plus 3 common to both the numerator and denominator. And in the reduction, okay, we still have m plus 3 from the 1 m plus 3 from the numerator left over, and that is going to be the simplified result of adding these two fractions together. Now, looking at what we have and still working with fractions, and we have, say in the case number 43, okay, so here we have 2 over 9c, and we have plus 7 over 15c cubed. And just looking at what we have here, to be able to add the fractions together, like what we had in 41, we need the denominator to be the same. So just for 9c, okay, or just the constant 9. Again, in terms of prime factorization, now 9, okay, have factoring out to 9 times 1, or taking out prime factors. Okay, we have 3 times 3. As for 15, okay, you have like 1 times 15, but in terms of prime factors, okay, we have 3 times 5. So you have with prime factors, okay, we have with the numbers 3 and 5. And for what we have in terms of what's going to be the least common denominator, now I'm just going to mention this too. You have the variable factor at c. And for the least common denominator, okay, so you're looking at taking with 3 and 5, okay, the greatest representation of each of the prime factors from any one of the factorizations, like we have with 3. It appears once from 15, but it appears twice from 9. So the highest representation of 3 in appearance-wise stems from 9. And in the case of 5, this will come only from 15. And for the variable factor c, you're looking at the higher or highest degree appearance of c, and that's going to be c to the third. So we have the least common denominator. We have 3 times 3 is 9, times 5 is 45, and we have c cubed. And so we have with the sum of the terms. So I'm going to write both of these in terms of a common denominator, and if I put it in terms of the least common denominator, okay, so I have 2 over 9 times c. So you have, if I take 9 into 45, okay, this will be 5. And c into c cubed is going to be c squared. So the first ratio is going to be multiplied by 1 in the form of 5c squared over itself. And we have for 7 over 15c cubed. Okay, so you have 15 into 45 will go 3 times, and we already have c cubed in this denominator. So we're going to multiply by 1 in the form of 3/3. And both denominators, okay, we now have in the form of 45c cubed. And we can go ahead and combine the numerators. So you have 2 times 5c squared, so this will be 10c squared. We have plus 7 times 3, so this will be plus 21. And that is going to be the final result. Right. Now, in the case of but we have monomial or single term denominators as well as binomial denominators. And looking at combining fractions. Now we have, in the case of 48, we have 4 over m minus 2 minus 3 over m. Okay. And now for the least common denominator. Okay, so you have just a standalone m, and we have times, okay, the other factor, which will be m minus 2. And taking what we have here, so we have with 4 over m minus 2, and relating to what we have in the least common denominator. So we have the m minus 2 factor, but we need the m. So I'm going to multiply the first ratio by 1 in the form of m over itself. And we have minus 3 over m. And with this one, okay, I have the m factor, and I need to cover the m minus 2 factor. And so just carrying what we have now. So both denominators will be m times, okay, the quantity of m minus 2. And looking at combining the numerator terms, and I'm going to take this just a step further. So we've got 4m, and we have minus 3 times all of m minus 2. So we have 4m, and you have minus 3m, and negative 3 over negative 2 is going to be a plus 6. And so for what we have in the result, so this will come out to m plus 6. And we have all over m times, okay, the quantity of m minus 2. All right, now in looking at combining fractions, okay, now we have a trio in the case of number 52. Okay, so whereupon we have 5 over t squared plus 4 over t plus 2 minus 3 over t. And looking at establishing the least common denominator. Okay, and just for the standalone single terms, okay, so we have t and t squared, and in the least common denominator, not the greatest common factor, but the least common denominator, you're looking at the higher or highest degree representation of each factor. So with the factor t, highest degree representation is going to be t squared. And then we have the other distinct factor, which would be t plus 2. And to be able to unite these fractions into a single expression, yeah, all of these will have to be expressed in terms of the least common denominator. So for what we have here, for the first item, okay, so we have 5 over t squared. And okay, so we have the t squared factor. But this one is missing, okay, the t plus 2. So I'm going to multiply by 1 in the form of t plus 2 over itself. Then we have plus 4 over t plus 2. In the case of t plus 2, okay, so we have t squared to multiply out. And we have minus, okay, we have 3 over t. And looking at what we have in the setup. And this is perhaps the trickiest one here. Okay, because you have, first two ratios at least have the completion of at least one of the factors in the least common denominator. Whereas in the case of the last ratio, you have only at most partial completion. And we have t, but you still have from t squared a degree left over. And we still have t plus 2 to take care of. So here we're going to multiply by 1 in the form of t times the quantity of t plus 2 over itself. And so for what we have here is they have t squared times the quantity of t plus 2 in the denominator. And for the numerators, okay, so I have 5, and I can go ahead and distribute over t plus 2, so this will be 5t plus 10. And I have plus 4 times t squared. And we have minus 3t. I'm just going to add a little step here, so we got minus 3 times t. And again, you still have distributing over the quantity of t plus 2. And if you go ahead, if you already see the distribution in advance, that's fine. So you have 5t plus 10, and we have plus 4 times t squared, and we have with the distribution, so we have minus 3t squared minus 6t and we have all over t squared, okay, times the quantity of t plus 2. And so combining like terms, and we're just going to put these in reducing degree order. So we have 4t squared minus 3t squared. So you have t squared, and we have 5t minus 6t becomes negative t. And we have plus 10. And we have all over t squared times the quantity of t plus 2. Okay. And that would be the result in this one. Right. Okay. And we're soon going to be looking into working with equations of various types. But for what we have in the meantime, okay, let's see what we get. Say if we're looking at combining ratios, and we'll say that we have just for the next few moments, let's see what we get for 1 over 40 plus 1 over 100 minus 1 over 18, and determine just what the exact fraction is going to be. Okay, so if we look into these ratios, and let's say that if we sort of initiate things through prime factorization. Now we have with 40, okay, you can select other than 40 and 1, you can select any two numbers that would go into 40, and we could go with something like, let's say, 2 times 20. Now 2 is a prime number, since the only positive numbers that go into 2 will be 1 and the number 2 itself. For the number 20, okay, you can't say the same thing. So if I branch out further, factoring out 20, okay, so we have, say 20, we can say we have is 4 times 5. And as for what we have, now 5 is a prime number, 2 is a prime number. However, 4 can be branched out further to 2 times 2. So 40, in prime factorization terms, you have 2 times 2 times 2 times 5, or in exponential terms, you have 2 to the third times 5. And let's say that in case of 100, say we have 10 times 10 as a possible combination, and the 10s will each factor out to 2 times 5. And just organizing, so you have 2 times 2 times 5 times 5. And as for 18, okay, we can say that we have, let's say 2 times 9. And for what is going to result here is that now 2 is a prime number. 9, on the other hand, can be factored to 3 times 3. So again, we have with the prime factors, okay, so we have with the numbers 2, 3, and 5. Now for the least common denominator, okay, so you're looking at the greatest representation from the 3 factorizations of each of the prime factors consolidated. Okay, so we have 2, it appears once here, twice from 100, and it appears 3 times from 40. As for the number 3, okay, it appears twice. And for 5, it comes once from 40, and 2 times from 100, and not at all from 18, so we have 5 times 5. So it's going to turn out that for the least common denominator, we have 8 times 9 is 72. 72 times 25. This will come out to a rather large number with 1,800. So upon looking at consolidating the numbers, okay, so I have 1 over 40. And if I write in terms of the least common denominator, okay, so 40 will go into 1,800 45 times. And we have plus 1 over 100. And writing this as a fraction with 1,800 in the denominator. So we multiply this ratio by 1 in the form of 18 over 18. You have minus 1. 18 will go into 1,800 100 times. So we have in the rewrite, okay, we have all these fractions will have a denominator of 1,800. And looking at the numerators, so you got 45. Then we have plus 18. And then we have minus 100. And here we have 45 plus 18 is 63. Take away 100, and this is going to be a negative value, so that's going to be minus 63 minus 100. Okay, so that's going to be a negative 37 over 1800. And that is going to be the final results in this case. All right. Now, we are going to get back into factoring, but as we cross over into the realm of equations, okay, there is an introduction to various types of equation relations. And we have categories here where we're going to have, I guess I could put contradiction first, but I'm going to put it in this sequence. You have conditional, contradiction, and identity. And in terms of the categories, okay, so we have for a conditional, a conditional is going to be an equation that is going to lead to a finite number of solutions, or equation with a limited number of solutions. And just as kind of a quick example, if you're looking at solving for x, and we'll say that we have here so we have 2x plus 5, okay, is equal to 17. And if we're looking at solving for x, so we can get the x term by itself. So we get 2x by itself on the left-hand side, okay, by removing 5, by taking 5 away from both sides. So left-hand side we have it 2x, and to the right I have 17 minus 5, which will be 12. And then undoing the multiplication by 2 upon dividing. So you have 2x over 2 is equal to 12 over 2. And so x is equal to 6. Okay, so this is going to be a case of what we have with the conditional. So there's only one solution, so you have a limited number of solutions, and this equation is true on the condition that x is equal to 6. So you have a conditional, limited number of solutions. Now, in terms of what's going to be categorized as a contradiction, okay, now for a contradiction, okay, that in mathematical terms, this is going to be an equation with no logical solution. And we can take, just as an example, and trying to solve for x. And we'll say that we have 2 times, okay, the quantity of x plus 3 minus 4 is equal to x plus x minus 5. Okay, so we're trying to find out what we have in x such that both sides are going to be equal to each other. Okay, so looking at distributing, okay, so we have 2 times the quantity of x plus 3, so this would be 2x plus 6 minus 4. To the right, I have x plus x is 2x. We have minus 5, and combining the 6 and the negative 4, so I have 2x plus 2. Again, we have equal to 2x minus 5. And if we combine x terms together, and guess what? If we combine the x terms, we're looking at subtracting 2x, and that's just going to be elimination of the x terms. And so to the left we have 2 is equal to negative 5. And guess what? There's nothing x in x that is left over. And you could practically plug in anything for x, and you would still come down to a statement where 2 numbers are said to be equal to each other when in fact they are not. So this is a false statement. So this is kind of a road that leads to nowhere in the setup. So you can plug in anything for x, negative, positive, 0, and you're still going to have this imbalance. So in this case, okay, we have no solution. Okay. So again, this is going to be a case of a contradiction. The contradiction being where you have the process to lead up to the result where we have that 2 quantities are said to be equal to each other, and yet they're not. Okay, so conditional has a limited number of solutions. A contradiction has no logical solution. And then we have, for the remaining category, okay, we have with an identity. And we have for an identity, okay, this is going to be an equation. That would end up with an infinite number of solutions. And we can take just an example. If we're looking at solving for x, and here we'll say we have 3 times the quantity of x plus 4. And we have is equal to x plus 6. And we have plus 2 times, okay, the quantity of x plus 3. So looking at what we have for x, okay, such that both sides of the equation will balance. Okay, so you have 3 over the quantity of x plus 4. And we have upon distributing, so you have 3x plus 12 and we have is equal to x plus 6. And distributing 2 over the quantity of x plus 3, we have 2x plus 6. Okay, so we have 3x plus 12, and if we combine like terms together, we have x plus 2x comes out to 3x, and 6 plus 6 is 12. And you already see the pattern here. We have identical terms. On both sides of the equation, and if I take care of the variable terms, again, just like the earlier case, okay, we have to be identical, and they're going to cancel each other. Okay, and for what we have left over, now, with the variable terms going out, there's nothing further we can do with x, but for the reduction, okay, we're down to a statement where two numbers are said to be equal to each other, and that they are actually equal. And so this is a true statement. So what this is going to signal is that you can plug in anything for x, not just any one number, but anything 0, negative, positive, and both sides will still come out equal. It could be 5, it could be negative 97,004, and you will still have both sides to equal and ring true. Okay, so in this particular case, all right, you're going to have an infinite number of solutions. And there's a way you can display this. You have for the solutions, okay, you can see we have all real numbers. Another way you can represent this is have with a capital R. And there's another notation we'll be looking into, and this is going to be interval notation. And this is what we have going continuously between negative and positive infinity. So this is symbolic notation for all real numbers. And again, this equation is yet another situation of what we have with an identity. Now, in the case of what we have regarding working with equations, and we have in the next realm, okay, so going back to pretty much what we have with factoring. And we're going to have with quadratic equations. And we have by definition. So for a quadratic equation, we're going to have a second order equation. Whose standard form is going to be, okay, so we have, say in terms of the letter x, you have ax squared plus bx plus c is equal to 0, whereupon a cannot be equal to 0. Again, what I mean by second order equation, okay, we have in a single variable, okay, the highest order term is going to be to the second power in the variable of concern. So you have ax squared plus bx plus c is equal to 0. And again, if a were equal to 0, well, the x squared term would just end up vanishing altogether, and we would have at most a linear equation. Now, there are methods of solving quadratic equations, and one of which, and this reverts to factoring, and this is going to be there's a property called the square root property of equality, but I'm going to go with the zero product property. And for what we have here with the zero product property, and this property is not limited to just two terms. But say if you have expressions, and we'll say a and b. If a times b is equal to 0, and that is true, then at least one of the following has to be true. If a times b is equal to 0, then either a has to be equal to 0, and if it is not, then b has to be equal to 0. And say that in terms of quadratic equations, see we have in terms of solving for x, and we'll put up at least a couple of cases here. Say we have in solving for x, if we have something like x squared plus 7x plus 12 is equal to 0. Okay, so you have a trinomial that we can factor. Again, so we have with x squared, this will factor out to x and x, and then factors of 12 that will add up to 7. Okay, so you have a positive 4 and a positive 3. Now we dealt with restricted values in terms of what x cannot be, but now we're looking at this setup in terms of what x has to be for there to be a solution. So for x plus 4 equal to 0, okay, for this statement to be true, okay, I take away 4 from both sides, so I have x equal to negative 4. And for x plus 3 is equal to 0, so we have that x is equal to negative 3. And I can go back to the original setup. Okay, so if I take negative 4, again, the square of negative 4, or negative 4 times negative 4, this will be a positive 16. 7 times negative 4 is negative 28. 16 plus negative 28 is a negative 12. Negative 12 plus 12 is equal to 0. So negative 4 will check out. For negative 3, the square of negative 3 is positive 9. 7 times negative 3 is negative 21. 9 minus 21 is negative 12 plus 12 is equal to 0. So for this solution, this is kind of like, this equation is like a conditional that is going to have two solutions. So we have negative 4 and negative 3 for the results. Now, let's say that if we have, let's say we have an equation that is not quite in standard form, and we'll say that we have that x squared say we have something like x squared plus 20 is equal to 9x. Okay, so I don't have this in standard form. To get it in standard form, the terms had to be in descending degree order and also set equal to 0. And I can make amends here. So I have x squared on the left, and I can move the 9x over by subtracting. Okay, so we have x squared minus 9x plus 20 is equal to 0. And for what we have with x squared, we're going to have x and x. And factors of 20 that will add up to negative 9. You can see we have negative 4 and negative 5. And again, for this expression to be equal to 0, we must have each of the factors equal to 0. So you have with x minus 4 and x minus 5. If I set equal to 0, we're going to have one solution. We're going to have x equal to 4, apparently, and then the other apparent solution will have x equal to 5. So just quick check, 4 squared is going to be 16, plus 20 is 36. 9 times 4 is also 36. Now for 5 squared is at 25, plus 20 is 45. 9 times 5 is also 45. Okay, so you have two solutions, an x with 4 and 5. And let me give you one that has a little different setup. Now let's say we have something like negative 2x squared minus 4x. So we'll say we have negative 2x squared minus 4x plus 6 is equal to 0. And this type of problem you can deal with in at least any couple of ways. Let's say that working with what we have here, let's say if I want the trinomial to lead off with x squared. So if I were to factor out negative 2, I would have negative 2 times the quantity of x squared plus 2x, and negative 2 into positive 6 is going to be a negative 3. And here we have negative 2 factored out. For x squared plus 2x minus 3. Okay, so you're going to have the quantity of x plus 3 times that of x minus 1 is equal to 0. Now for what we have here, okay, now there are 3 factors that we have in the layout. And now negative 2 is not doing anything for us in terms of adding, subtracting, or multiplying, or even dividing x. It's just a constant. So it's kind of like a dummy term, in other words. But now for the x factors, we have x plus 3 and x minus 1. And if we set each of these equal to 0, we're going to have the x is equal to negative 3, and also x is equal to 1. So you're going to have a couple of solutions with negative 3 and positive 1. Okay. And I would just mention, just to kind of provide a little bit of clarity, what you could also do is that since we're working with taking care of the constant, what you could do is that you can divide the equation. Okay, so you have dividing the equation by negative 2. Okay, and so with this pathway, if I divide by negative 2, I got x squared plus 2x minus 3 is equal to 0. And if you divide as opposed to factoring out, you're still going to have the same pathway. So you have the quantity of x plus 3 times that of x minus 1 equal to 0. And again, just setting each factor to 0, we're going to have the same results still. Okay, with negative 3 and positive 1. Okay, and let me kind of leave you off with this. Okay, there's I'll put a little hold on this one. Okay, there's the zero product property, and there will be other approaches that we will also be looking into, and this will be in the case of the square root property of equality, and that's going to be kind of like a bridge that's between the zero product property and then looking at the quadratic formula, okay, which is another viable approach, especially if you have a trinomial that cannot be factored in terms of integer coefficients. All right, and let me go ahead and mention for next time. Okay, again, so you had the first Alex assignment up, and now go ahead and be looking at on page 68. Okay, but we have working with equations this time around. So 24, 26, 28, and that's with the conditional, contradiction, and identity, and then where we have the quadratic stuff to come in. Just be looking at 30, 34, 35, and rounding out the rest, okay, numbers 40, 41, and also number 64.